experience with the Engineering and Technology Policy Master Program that we launched this year at our École Nationale d'Ingénieurs de Tunis. And I would like to remind you all, and I believe most of you know, that ELITE is the oldest engineering school in Tunisia. And not only that, and yesterday, the director of ELITE spoke of the fact that ELITE was always a leader in Tunisia in starting new engineering training programs. And among these programs, I always go back and talk about the industrial engineering program that started long ago and has been so long giving excellent results. And I can see actually some of my students here on the table that became colleagues. So that really gives me a great pleasure to see such kind of impact through these kind of new programs. So remaining with this, with these dynamics and academic leadership, myself and other colleagues, primarily Professor Bahri Zee, Professor Hatem Hani, we saw there was a great deficit in policy analysis capacity in Tunisia. And as you well know, you can have in a soccer team great players made of Ronaldo, Zidane, and what have you, but if you don't have a good coach, if you don't have a good medical team, that soccer team won't go that far, because you need to really orchestrate the activities, the training, and even the strategy of that team for it to be a winner. It is actually the case in Tunisia. In Tunisia, we have, of course, governments made of ministries, and these ministries are called to come up with public policies. And for complicated and even complex problems, that requires really high skills and capacities. Unfortunately, we don't have in Tunisia any formal academic training for these kind of capacities. And not only in Tunisia, our experience also showed us that this problem is a little bit everywhere, in the region, and especially in the continent, that means Mother Africa. So we decided that we're going to dive into this experience, knowing that I am an engineer, Bahri is a physicist, Hatem, of course, is an economist, and maybe the closest one to this area, to actually create an interdisciplinary program between engineers, political science, and whatever remaining areas of decision-making to start building capacity in public policy, but specifically in science, technology, and innovation. Because we are convinced that for Tunisia and the developing countries all over Africa, if they want to develop, especially in the 21st century, they have no other choice but to leverage STI according to their context and according to their comparative advantages. So we were able to put this idea together, to get in touch with many colleagues and institutions such as UNESCO, such as the African Development Bank, and other institutions, as well as our friends from Bremen, who were with us from the start of developing this idea, and we gathered quite a bit of feedback. I must not also forget Georgia Tech, my graduate school. Also, their political science department was of great support to us in building the content of the actual master program. So, and right before we launched this master program, we had a gathering with top specialists in the area of policy analysis with the help of UNESCO. And this was about 6 months ago or so. And we reviewed actually the curriculum of this master program, and we gathered as much feedback and as much recommendation, to enhance this program, and not only enhancing it, but also to start, cooperation and partnerships and networking in order to strengthen this, young and new program. So this is really a very, very quick presentation as to how this program was born, if I may say so. I would like to finish this very short presentation by saying not only this program is meant to participate, because no one program can respond to the all needs of any country, but can only participate to help the emergence of experts in policy making, especially in STI. But also, we would like very, very soon to open this master program to students from Africa, from all African countries, because we believe our role is not only to respond to the needs of Tunisia and the region, but also to respond to the needs of the whole continent. And we are now working on this dimension, and we hope to succeed in bringing in African students. And as you well know, the basic challenge there is not bringing in the students, but finding the funds to bring them in and allowing them to follow this training. So I hope that in a couple of years or so, we can meet again, and there will be among the ETP students some African students who will be registered in our ETP program and working on their on policies of relevance to their country. So here is somehow the overall philosophy and how things started, and I hope also that the program will see some visibility even in Tunisia, with respect to other ministries, with respect to other civil societies, to give us support, and so that we can also respond to their needs while getting their feedback. Now, I'll let my friend Professor Bahri give you more details as to the inner working of the pedagogy and the process of selecting the ETPists, we call them the ETPists, who are the students studying in this ETP program.
C'était un peu la mise en contexte de construction. Mais la construction est aussi sur le terrain. Et je pense qu'il est encore en construction parce que nous sommes en train de réfléchir sur l'expérience qui se déroule devant nos yeux. Avec des apprenants, des étudiants, on ne sait pas comment les appeler d'ailleurs, ils sont les apprenants. Je vais parler très rapidement du processus résumé, parce que ce n'était pas évident. C'est la première année, donc l'année de toutes les difficultés. La difficulté d'abord dans les délais, parce que nous avons été habilités, homologués assez tard, étant donné que même la commission d'habilitation trouvait des difficultés pour situer le programme parmi les programmes classiques qui sont souvent, en général, pointus, spécialisés, loin d'être multidisciplinaires. Et se retrouve devant un programme nouveau dans une école d'ingénieurs qui parle de politique scientifique. Bon, on retient seulement politique là. Et beaucoup croient que le programme doit être dans la faculté de sciences politiques. Bon, après multiples discussions, et dans le cahier de charge, c'était clair que l'ambition est de faire un programme de conception et d'analyse de politique scientifique, technologique, construite sur le noyau dur des sciences de l'ingénieur, de la démarche ingénieur, des outils de l'ingénieur. Bien que nous ne sommes pas du tout, nous n'avons pas été du tout fermés, et nous ne serons pas sur la spécialité des apprenants, qu'ils soient ingénieurs ou scientifiques, ou même dans les spécialités économiques. Je pense quand on trouvera le moyen pour les intégrer et adapter notre pédagogie pour qu'ils puissent être capables d'avoir les outils. La sélection a été basée sur une grille d'évaluation qui prend en compte le dossier, les diplômes, l'expérience professionnelle, et puis la communication dans l'interview qui a été organisée avec les candidats. Et il se trouve que nous avions, malgré les délais qui étaient étroits, nous avions 65 candidats éligibles. Nous avons retenu une cinquantaine, convoqué une cinquantaine pour l'entrevue, et une quarantaine se sont présentés. Nous avons retenu 30 candidats, 30 admis. On se stabilise maintenant autour de 20, 25, sans parler bien sûr des difficultés d'activité que nous sommes amenés à résoudre à un certain moment. Il se trouve que le profil des candidats, c'est pratiquement 50% dans les institutions publiques, ministères, agences, technopoles, laboratoires, centres de recherche, et 50% dans le privé, des sociétés, des compagnies. Et je pense avoir compris que ce sont des initiatives privées, personnelles, des candidats de se présenter pour leur projet professionnel, pour leur ambition, pour leur idée d'aborder des choses nouvelles. Donc on se retrouve avec public-privé 50-50, avec une petite légère majorité pour le secteur privé. Bizarre. Pour les spécialités, les profils, il y a une diversité de profils de spécialité, je parle, une grande diversité de profils. Une forte majorité de formation d'ingénieurs, il faut le dire. Nous avions deux seulement qui étaient non-ingénieurs, qui étaient des économistes, disons, peut-être plusieurs qui sont partis. Nous étions contents d'avoir récupéré 2 profils qui travaillent à la présidence du gouvernement et qui étaient en charge du e-government. Malheureusement, des contraintes de personnel les ont poussés à quitter. Bien, nous avons commencé avec cette cohorte et nous sommes en train d'étudier le déroulement des choses. Et nous avons suivi 2 standards dans le programme. Premièrement, le processus de Bologne, sur la charge horaire, sur la pédagogie, j'en parlerai très rapidement tout à l'heure. Et un autre standard qui est plus intéressant, c'est le standard du métier, Policy Skills,
Policy Skill
Framework. Un standard, un référentiel du métier adopté au Royaume-Uni, Grande-Bretagne, pour le métier des analystes de politique en général, pas nécessairement politique scientifique. Et cette grille de lecture, de référence, était très importante pour l'intérêt dès le départ, parce que le master était très différent des masters généralement qu'on donne à l'université. C'est un master qui vise des compétences et probablement un métier. Et nous avons tenu à ce que ce référentiel soit sous la main de tous les intervenants, enseignants, les apprenants aussi, pour pouvoir ajuster leur pédagogie, ajuster leur programme pour, dans la majorité des cas, c'est pas dans tous les modules, mais dans les modules les plus importants, au moins se poser la question, qu'est-ce que l'apprenant aurait comme compétence à la fin du module? Je reconnais que c'est difficile dans la première phase, dans la première cohorte. Mais c'est un référentiel auquel on tient. Le programme tourne autour de 4 axes. Un premier axe ou pôle de compétences tourne autour du système national d'innovation. À peu près 8 à 10 modules. Un deuxième axe concerne le système, l'analyse de la politique elle-même, où il y a le foresight, il y a system modeling, il y a tout le noyau dur du master. Un troisième pôle ou axe concerne la coopération internationale et la diplomatie scientifique, les relations, le réseautage et la collaboration, bien sûr, entre pays et entre groupes. Nous savons que la politique scientifique est généralement connectée avec, une échelle beaucoup plus grande. Un quatrième axe concerne les sciences humaines, sociales et politiques, qui part du système politique, parce que c'est le contexte dans lequel nous appliquons, le candidat applique les outils de l'analyse politique. Il y a aussi STI and Society, l'interaction entre sciences et technologie et société. Il y a aussi le Leadership and Change Management. Il y a un certain nombre de modules qui donnent un peu le plus important que nous ne donnons pas en général à l'université. Les sciences molles, mais pas si molles que ça, qui deviennent vraiment intégrées à la formation, qui doivent être intégrées, ils ne sont pas totalement intégrées dans les formations de ce type, surtout d'un haut niveau. La pédagogie elle-même, c'est une pédagogie active qui est inspirée, bien sûr, des objectifs du processus de Bologne, c'est-à-dire un grand intérêt au travail personnel de l'apprenant. Travail personnel par l'auto-formation, la lecture, le résumé, les rapports, mais aussi les projets. La formation par projet, ils ont un projet de 10 semaines chaque semestre. Et je parlerai des projets tout à l'heure. Il y a aussi les débats, les conférences, les événements comme celle-ci. Une formation qui les met en contact avec les décideurs, avec les responsables qui conçoivent ces politiques, ou les bénéficiaires qui les utilisent. Nous avons aussi des case studies, bien sûr, des études de cas. Tout ceci va venir, même si on ne réussit pas dès le premier semestre ou dès le deuxième, il est absolument dans la philosophie et même dans la pratique, dans l'organisation de l'emploi du temps et dans l'organisation du plan d'études. Si maintenant je parle un peu des projets parce que c'est le plus important pour nous, ils sont maintenant en train à part les mini-projets qui sont donnés dans les cours et des travaux personnels qu'on leur demande en dehors de la classe. Vous savez que le processus de Barcelone donne 60 crédits par an, 30 crédits par semestre et 1800 heures par an pour l'apprenant en globalité. Seulement 20 à 30% sont réalisés en classe. 20 à 30% de 1800 heures, ce qui nous ramène un peu autour de 300 heures, pour pouvoir faire en sorte que l'apprenant puisse avoir le temps de se former et de s'auto-former. Alors, il y a des difficultés, avant de parler du projet. La difficulté que nous sommes en train de sentir aujourd'hui, c'est que nous n'avons pas eu suffisamment de temps pour faire des contacts avec les sponsors de ce master. Je veux dire, pour ceux qui travaillent, leur supérieur hiérarchique, la direction dans laquelle ils travaillent, l'organisation dans laquelle ils travaillent. Et nous sentons que c'est fondamental pour les profils qui travaillent, qui sont en exercice, d'avoir l'engagement de leur établissement, l'organisation. Parce que nous voulions, dans notre conception, que les projets dans lesquels ils travaillent ne soient pas des projets différents des dossiers qu'ils sont en train de traiter. C'est très important. Nous n'avons pas eu le temps de faire cette connexion avec l'administration, leur administration, qu'elle soit privée ou publique. Ce qui est très intéressant pour eux, d'abord, parce qu'ils intègrent leur formation dans leur travail, au moins à travers les projets, et puis pour nous, pour écouter un peu la demande ou les idées, les propositions des donneurs d'ordre. On est les bénéficiaires, en tout cas, ils sont aussi bien donneurs d'ordre avant et bénéficiaires après. Eh bien, nous le sentons, ceci, dans leur dispersion. Ils sont un peu dispersés parce que le travail d'un côté, le master de l'autre. Nous n'avons pas voulu. C'est non voulu. Nous avons voulu aligner le master avec ce que font exactement. Bon, je peux parler beaucoup plus longtemps, bien sûr, sur ça, et j'insiste sur les projets parce que c'est très important. Les projets sont du type, par exemple, ce sont leurs premiers projets du premier semestre, de type Innovation for Pro-Poor Innovation, Triple Helix Model. Ça peut paraître un peu théorique, mais c'est des entrées en matière. Il y a aussi des gens qui travaillent sur le gisement de phosphate de Sawarten, un gisement qui n'est pas encore ouvert, mais c'est un projet. Le problème, comme vous le savez, le problème du phosphate en Tunisie est un problème énorme, qui pose problème dans la façon, dans la politique des ressources premières est faite en Tunisie, et probablement aussi, surtout pour le phosphate, ça pose un problème. Et donc, il y a aussi les interfaces, le problème des interfaces et des bureaux de transfert de technologie qui est mis sur la table, et donc des problèmes réels que nous avons eu l'occasion de toucher. Je ne vais pas être long, je vous remercie et je passe la parole à Noël.
Us as ETP students, almost of us are in professional positions, and through these positions we are believing that things are not going well, and even they are going worse, and complaining among our colleagues, our friends, on Facebook or in coffee will not solve the problem. And this problem cannot be solved by a gift or by a miracle, but this problem will be solved by a change. This change needs to be made certainly by us. So we decide to take this responsibility to start working to make this change, to make things better. We find this program as an opportunity to have solid knowledge and tools to realize this change and go ahead the revolution objectives and dreams. And that's why we are here in this master program.
Thank you very much, Noel. Here is a testimony of one of the ethicists and one of the dynamics one actually, and we feel satisfied, not yet saying happy, about the fact that the youth finds in this program a great utility to respond to their needs, especially after the revolution, where nothing seems to be moving, and consequently they take this as their responsibility to make the necessary change. Thank you very much.
First of all, I'm from the e-learning center of the university. The e-learning center provides e-learning services for the university members, especially students and the teachers. And we provide e-learning services like the learning management system and we have a test center with 120 PCs where we do electronic exams, and we have media center. We produce video-based lectures similar to MOOCs, what I will present now, and we do consulting and do workshops and qualification for the teaching staff in e-learning issues. I did this presentation in Bremen, and some of you have been in Bremen, so I suppose you will know the most issues of this presentation. But I tried to give, of course, the basics, but also some up-to-date statistics and trends about development. And I tried to give also not only the perspective of German and Bremen University, but also did some small research on the internet to find out how the state of MOOCs in Tunisia. So first of all, what is MOOC? MOOC stands for Massive Open Online Course. Massive because it's for a huge number of students, usually 10,000, 100,000 of students can register for these courses and in one session. And it's open. It's open for everyone worldwide and independent of the education background. And it's usually for free. Usually because we will see later there are some things we have to pay for. And it's online, of course, and it's a course you have to register. You can register to that course, you get support, you do assessment, and at the end, when you complete the course, you also are able to get some kind of certification. So in general, online courses, there was a long time online course. We in Bremen had it, I think, from the beginning of 2000. But the big difference between the classical online courses we had and other universities have and the MOOC is that, for me, of course, it's massive, huge number of students, but the most important thing is that it's open. So everyone in the world, independent of education background, can register to this course, get support, and can complete and get a certification. This is very strong issue of the MOOCs. So what do MOOCs promise when they start to become a hype? Of course, because of the openness, it's open up higher education, and this by providing affordable and accessible and flexible and fast-track completion of university courses, and this for free or at low cost, because there are some courses we have to pay for at the end. And this is for everyone who is interested in learning. So there are no limitations. So when you look on the MOOC market, you will find two types of MOOCs. One is called XMOOC and the other one is called CMOOC. XMOOC is this traditional kind of lecture we know at universities. They are formal, they're structured. We have traditional relationship between teachers and learners. And the CMOOC is based on the connectivism theory of learning. And it's changed the relation between teacher and learners, more learner-centric, and content is not provided a tool for students, but students are expected to create content and expand it. It's more participative concept behind. And for all these networking issues in this connectivity MOOCs, you need, of course, multiple technologies. Of course, you have the learning environment, but also you need blogs or Twitter or Facebook or other social media platforms. And the most MOOCs you will find on the market are the XMOOCs. I suppose maybe 90% or more of the MOOCs are classical XMOOCs. And at the beginning, when MOOCs became very popular, one of the most popular MOOC was a MOOC from Sebastian Grun about the introduction to artificial intelligence. And this MOOC, at the beginning, had more than 160,000 students. And when we look on the completion rate, it's about 13%. It's low, but it's still 20,000 students who run and did this course at the end. And looking at the completion rates, this is not the problem of MOOCs. Discussions always given as a problem, but I would say it's more an issue, and we will see later what is the background of this low completion rates. But here you can see that the higher the number of participants, the lower the completion rates of the MOOCs. This is typical for MOOCs in general. Another good example is this MOOC about English language learning from the Open University of UK. They have a platform called FutureLearn, and in this MOOC, 370,000 students registered, and this MOOC is completely free. Only if you want to get some kind of statement of participation, you have to pay for that. In this case, you pay £29. But the rest, registration and support and assessment, is completely for free. And looking at the growth of MOOC, so we had a time it was maybe between 2008 when MOOC started, the first MOOC started, and 2012-13. It was a time they called it the MOOC hype. So in 2012, the New York Times defined this year as the year of the MOOC because of this popularity, and it became then visible in the media and press and universities. In Germany, for example, started to think about MOOCs, about strategies of MOOCs, so about the potential for the universities. This time it was a big topic in German universities. Later on, they said the hype is over. They still continue to grow. So 2014 and 15, the number of courses doubled each year. And now we have more than 4,000 courses online, and with more than 35 million students. And these all courses are for free, so you can run the complete course for free. And this prediction from the market research provider Center Research, they said that the MOOC market will grow between 2014 and 2018 about 56% of compound annual growth rate. And the key market driver, based on this report, will be the increasing cost of education. And they see as a market challenge the thing I told before, the low completion rate of these MOOCs. They see it as one challenge. And one key market trend they see in this MOOC development is the big data tools and analytics, because you have a huge number of students who register and run for these MOOCs. So you are able to collect as many data about the learners as possible, and based on that you can try to optimize your pedagogical concept or other issues. Of course, the students have to confirm for this data collection, but this is a huge number. If you only maybe 10-20% of the students confirm or allowed to collect this data, you have a big base, database basis to make evaluation on this learner behavior. So who are the major MOOC players in the market? And this is based on the number of courses. And the biggest player in the market is Coursera. This is a commercial provider, and they have up until now a total funding of $146 million. And the last big funding they got last year, about $50 million. So it's a big market still. And they have more than 1,000 courses and 50 million users. The next big one is edX. I didn't find any up-to-date funding amount, but they have also high funding, I suppose. This may be the only one non-profit organization that provide MOOC, and it's a cooperation between MIT and Harvard. And one other big player, you cannot see it on this figure, but university is the third big player. Regarding the funding, they have total funding, they have 160 million funding, and they also last year got, I suppose, something about 40-50 million funding for the platform. And their partner are Google, Facebook, and AT&T, and they mainly provide courses about computer science and programming issues. Here the number of courses are as calculation, but I suppose that they have a huge number of students behind. And looking at the distribution of the MOOCs by subjects, so in the beginning it was more computer science subjects, but you can see that it's more broader. You have social science, you have business management, you have art and design, you have humanities, education and teaching. So it's a bright subject area as they provide. An interesting thing is that we at our institute in ZMNL, that we started a European project last year, and this project is about finding the gaps in soft skills before going to the labor market as students. And we tried to find out if it's possible to train soft skills with MOOCs. So there are many MOOCs, of course, especially for soft skills, but they have elements in the MOOCs where you can train soft skills. So why should the university offer MOOCs? So what is the perspective for that? The benefits are, at the beginning, was mainly marketing, to be visible worldwide as a pursue excellence or faculties and every other things. But of course, MOOCs also provide some kind of innovations in teaching and learning. That's why some universities also try to go to MOOCs. And the potential to provide high quality lectures for a huge number of students at low cost is also one benefit which universities try to go for. The challenges, of course, how to find a valuable model for sustainability, because you have to invest money and you don't get direct revenue because the courses are for free, so how to find a way to make it sustainable. And there are, of course, also concerns about pedagogy and quality. So the low completion rate was one of the issues, and accreditation, assessment, and groups, and other things. So the trends for MOOCs in 2015 was interesting to see. One is the death of the free certificates. That's what I said at the beginning, usually for free, because of course you can, of course, register, get support, do assessment, but at the end, if you want to get a certification, valuable certification, they start not to take money for that. And the university started with a new concept, they call it nano degrees, and Coursera call it specializations, and edX call it X series. These are all special collection of MOOCs for a specific area, and then at the end you get a certification for that, and you have to pay about $50–60 for each of the certifications. So, and the next trend which seems to come is that the MOOCs become more self-paced. So classical MOOCs have like classical lectures, starting and ending point, you have schedule, and this doesn't fit to the requirements of many users. So they start to make more safe-paced courses, so you can decide for yourself when to start to do the course and finish it. And then go to target more and more higher schoolers with a specific collection of courses. Examples are the edX High School Initiative and the Future Learn from the Open University of UK. And the purpose is about closing the readiness gap for university or college. And they want also to have students to get a taste of different subjects through introductory courses before starting university. So the trends in 2016 is an interesting one. Is that 6 universities from Australia, Europe, Canada, and the United States are seeking to establish a new alliance. And these organizations, MOOCs, are formally accredited by partner institutions. That means students who make a MOOC in one of the partner institutions, they get credit for it, and they can use this credit within their home institution. This is not usually for MOOCs that you get a credit which is accepted in your home institution automatically, and this is no new attempt to make it more formally and to guarantee this credit transfer. It's similar to this European Credit Transfer System, ECTS, but more on a global level in this alliance. So what's the German perspective? So in Germany we have 3 German platforms. So the biggest one is University, and then we have OpenHPI and Moin. Moin started 1 year ago, I suppose. And looking on this development, the German expert group for science and innovation pointed out in the report in 2015 that they recommend perceiving MOOCs more as an opportunity rather than a risk for education in Germany. And this shows, for example, that in Germany is still some kind of controversial discussion about MOOCs. And so here's a recommendation to perceive it more as an opportunity. And they also point out that MOOCs can relieve the universities from teaching standard knowledge and to create more scope for more research-oriented teaching and learning. And for Phasenregeln, for example, we have maybe this new learning or teaching paradigm about research-oriented teaching, and this fits well in this paradigm of the Bremen University. And the DAAD, the founder of our project here, see as a challenge for using MOOCs in higher education that they should consider or recognize critique and transfer. So this is one central challenge for MOOCs to be used in higher education based on this report of the DAAD.
So with all this having in mind, Germany starts in 2001 a campaign called commercialization campaign, and that was the idea to stimulate the technology transfer, especially through patents. They wanted to make the more efficient, to get some more money for the universities, and to make it more interesting for the researchers to exploit their ideas and their outcomes. And there some measures started. I said the commercialization campaign, and with this commercialization campaign, they started it by establishing patent licensing agencies like Innovi and others, and with a change of law, that was the elimination of the academic privilege. That means that before 2002, all inventions belonged to the university professors, and then they changed the law that all inventions of university professors belonged to the university, so that the university has the possibility to market their innovations. So the amendment of the law was that all inventions has to be disclosed to the university. Yeah. 2? Yeah. 2 minutes? That the patent registration, yes, and that there's a special revenue for the inventors. So the inventors will get 30% of all incomes. And that requires new competencies, new structures, and of course money. The competencies we need are listed here. You see, there are a lot of new competencies which are required at the universities. For example, knowledge about the patents, about the law, about sales and marketing, experience in negotiations, and so on. And for all this, universities need to have a team of experts which were not there. So the team of experts came through new structures and processes. The idea was either to have internal units, transfer offices into universities. The positive effect would be that they are included into universities. The difficult point is that's very expensive and only affordable for large universities. The other idea was to make specialized organizations for certain branches. It makes it easier to sell and to distribute the ideas into the branches, but it's difficult to get the ideas into the specialized companies. And so we came to the third idea, generic organizations like Innovi is. So we have it's quite easy to acquire, to get good inventions and to support universities and selling their inventions, but it's harder to address the branches of the industry. And the third thing is funding. Funding is necessary for all the things. just end of last year, the Signal initiative ended, and but there is a new initiative that's just started now again. There is a good funding, 40% for all patents and services. Also money for the further development of the inventions, and this is other money is added, for example, from federal state resources, from licensing revenues, and the universities pay some money for their own, for all the work and the patents. When you see how many patent applications are there, this is a list from applications in Germany. Most of the companies, it's written very close, but most of the companies, the first one is the Bosch and Schaeffler, that's all automotive industry. And when you put all universities of Germany together, you are about just the 10th person approximately with all the patents. Per year, 530 applications in Germany, so regional patent applications. In Tunisia, you have approximately 250 patent applications all over Tunisia, here in Tunisia. And when you compare it to Europe, Tunisia has only 10 patent applications in the European Patent Office. That's very, very low. You compared several times with Malaysia. They have about 300 patent applications a year. Morocco, for example, about 60 patent applications a year. So there's a way to go now. The funding was just evaluated, and some results of the evaluation were that the initiative has a positive impact of universities, of the regional economy where universities are. Another point is that that professors, and that's quite good, professors with patents do more cooperation with industry. So it's a vehicle for it. Some other aspects, especially about the aspects about the money. So all the investments in the patents are very different from the time in time where you can revenues from it. It takes a long time until you get the first revenues from your work. So the revenue expectations, even in Germany, are by far not met. There are some few blockbusters, some very good inventions which bring good revenues, but that's not very much. When you compare it to the USA, one of the biggest transfer office at Stanford universities, they started in the 17 years, and it takes a lot of time when they began to get the first higher revenues. Finally, after I think 40 years, it is good business. It takes very, very long time until you get money out of it. Finally, some further evaluation results. What is important is not only to have a patent, but also to work on the development of the ideas which are patented. And that's always a problem for universities, not to stop just okay to stop very early, but not to stop on research work with the companies on the patent issues and on the inventions. Yeah, and okay, the final result was funding was a good idea of all the things, and the changes at Germany and the German universities to become more and more professional.
Okay, so the title of my presentation is Industrial Internet of Things. I'm talking about Industrial Internet of Things and trying to present our concept, our view of Germany, and maybe also discuss a little bit how this could have an effect on Tunisia and actually your education in engineering. I would like to start to introduce at least the organization I'm representing here. So I'm the manager of the Rock Dynamics Lab, and this is a laboratory for demonstration and application of key technologies in the field of logistics and production. And it's part related, strongly linked to the Bieber Institute, and most of you had the chance to already visit our Bieber Hall. Bieber is an independent research institute, which is quite typical in the engineering field in universities in Germany. We are about 150 researchers and do applied research in the fields of production and logistics. So, as you might know, several industrial engineers work in our institute, doing really strong cooperation projects with the industry, small and medium sized, but also bigger global companies. So if if industry asks us what we can do for them, we say that we understand the challenge. This is very crucial. So our education or our whole institute is very aligned to the needs of the industry. But furthermore, then we know the latest technologies. So you have the end users on the one side, but the technology providers on the other side. You have trends in technology, and we think that we have a broad overview about all these technologies, and can industry bring together also some kind of catalyst. In our projects, and there are different measures, like European projects, national projects, or really contract research, we develop solutions together with the industry. And it's a great difference with respect to this consulting, something like this. We also transfer the research results and the know-how to the companies so that they really can profit from it. So today I'm talking about Internet of Things, which is one possible technology trend, or even a game changer in our industry. And first of all, Internet of Things is defined as developing everyday things to smart and connected products. So you bring new technology, communication technology into normal things. And there's a new, there are many products coming to the market for customers. For instance, if you consider Kickstarter or something like this, where everything gets somehow intelligent and you can control via your smartphone and so on. This is one aspect of Internet of Things. The other one, more interesting for us, is the industrial Internet of Things. So the same concept for all kind of industries and branches, like manufacturing, automotive, aviation. It really affects all aspects, energy, health. All these are the crucial industries for Europe, and I think also globally for the world. I just want to ask you one question. Who have heard of the term Industry 4.0? Yeah, just a few, yeah, okay. And this one is quite linked to the Internet of Things, but it's a very German perspective. also a perspective to disruptive changes in the industry. But in Germany, it is closely linked to the industrialization, so to the branches, to the industries that already have a great degree of automation. This is automotive, aviation, the automation provider itself, like Siemens, Bosch, and so on. But also the main player, SAP, so the software providers of management systems, enterprise resource planning systems, or manufacturing execution systems, are the player in this industry 4.0 vision. And 4.0 means that we are just in front of a new revolution in the industry, and all the measures until now gain for further efficiency in this field. So we have all this lean management, we have all this automation technology, and already a great degree of automation. But with connecting things in terms of Internet of Things, of smart connected products, this vision of Industry 4.0 somehow tries to make factories even more smarter and more efficient. And to give you an image how this could look like, it's a production site of BMW, and one robot, self-aware, context-aware, with sensors and actors, can measure that, for instance, the bearing needs maintenance. And well, this is a problem today because you have to stop, where you have to find a phase where you stop the conveyor belt, the production, and change this. Because still, all the processes are automated, but they are taught. You cannot, they are not context aware somehow. But in this context, where the bearing needs maintenance, the vision is that this robot asks the other robots or other parts of the system, who will do my job? So I need a brake, I need maintenance, who will do the job? And then the change of the system with this kind of technology is that one other robot can do this job. So he says, no problem, I do it, but of course we have to lower the speed of the conveyor belt. So all these, or autonomous control of this part is somehow the vision of the technology in this Industry 4.0. But still there is also the aspect of something beyond technology. Of course, Germany is still a company that earns money